Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast for Australia. I'm going to start you off today with my Twitter feed because there was an interesting tweet about a tornadic event that happened back on September the 10th. I just wanted to show you some, or maybe it was on the September the 9th that the tornado actually occurred, but it was posted to the web early in the morning on September the 10th. And it's a pretty impressive video down here. And what I found interesting about watching the video, let's just actually blow it up so you can see it a little bit better here. Let's start it over. Is a couple of things. Tornadoes are pretty rare across Australia compared to other parts of the world. And secondly, for many of us that watch this video in North America, we notice that the tornado is spinning clockwise. Now, at this scale, at the scale of a tornado, they can spin both directions, either way, counterclockwise or clockwise. Most of the tornadoes in the northern hemisphere, especially in North America, spin counterclockwise, but that's due to the large scale wind shear. So this doesn't have anything to do with the rotation of the earth. It doesn't have really anything, this tornado doesn't have anything to do with that. It certainly doesn't have anything to do with toilets flushing in different directions. But holy cow, what an impressive video here of a damaging tornado. I believe this is in New South Wales. What's interesting about all of this is just to show you, in the United States, we're quite used to these. So far in 2025, we've had nearly 1,480 tornadoes, and many of them right here in my backyard. I live in this part of Illinois, but you can see just a tremendous amount of tornadic activity here. And I just want to show you something kind of neat, maybe just to kind of get us started today. There's an interesting article posted or published in one of our most prestigious journals called BAMS, the Bulletin of the American Meteorological Society. It just talked about the worldwide distribution of tornadoes. So I wanted to show you what that looked like here. And it looks something like this. So it's actually the very unique geography of the United States, given this north-south running mountain chain called the Rockies, and just complete open access to the Gulf moisture that gives us this battleground for severe weather in this area. Look at Australia comparatively. So come visit sometime, and if you do it at the right time of year, I'll take you storm chasing. I will. It'll be a lot of fun because we have a lot of that stuff going on around here. Okay, there was another thing. Oh, by the way, this is just kind of a funny little tweet. There were some pretty nasty tornadoes. We had 22 just the other day running from South Dakota to North Dakota. And just get rid of the guy here. He's a famous YouTuber. But this is just some of the video of some of these impressive tornadoes that just went through here. But that's not what I wanted to show you. I wanted to look at this. There was some pictures posted of some of the bushfires that have been throughout parts of Australia. So I went looking for them on satellite and just wanted to pick up a couple of images here. So let's go ahead and throw on some coastlines and some place names. There we go. So I was looking at some satellite data back on the 13th, and you can see quite a bit of wildfire smoke here. And then if we flip over to the 14th, you can also see more of these individual fires showing up. So just kind of some important things going on here. And what's interesting is pockets of this particular region are actually wetter than average. Soil moisture is high, which means we had good vegetative growth going into this spring warmer time frame, giving us risk of bigger fires, honestly. That's the tinder that's going to burn. But I was thinking a lot about this map. This is the forecast, this is how much rainfall has hit compared to average for the first 17 days of this new month of September. And I was trying to figure out how well the models have been performing, because you can see there's a narrow corridor in through here that's been quite wet. On either side we were much drier, especially here in the coastal regions and down into parts of Victoria and into Tasmania as well. And many of the forecast models, while they got it right in Western Australia, did not get it right here. And I went back to just 2 weeks ago and said, well, what was being predicted? And this rain was well predicted, but this precipitation pattern here, especially as you get into Victoria and parts of New South Wales, was way overdone. And I think it was because of the positioning of the high pressure cell that was just off the coast, which we had detailed in the last forecast video. It also meant that because of the shift in that, we missed what was going on in Tasmania as well. So I think it's important just to look back and try to assess what is going on. But doing that in another way, let's look at the newest drought monitor data. It was just released. It's only got data on it through August. And I'm only looking at the 1 month drought monitor map here. And it is important to note that that drier region that I had just pointed out, for example, coastal regions of New South Wales up to Queensland here, remember in the previous month we had big areas of high pressure just pulling moisture into this region. We had flooding, right? So, but overall, I'd say that if you click this back 3 months, this is a much improved drought monitor over what it had been for the months coming up to this particular stage. And I'm quite curious to know what your feelings are on this. You can leave me a comment if you want, just to let me know. But I looked at the latest root zone soil moisture map as measured by satellite, and it's got a drier swath through here, but most of Australia is looking, somewhere in that 30 to 70 percentile. That's the white. And then we have a lot up here that's above 70 percentile, the 70th percentile, in terms of moisture. Maybe that's what's creating the environment that is needed to get these fires going that we've seen up here in the north, primarily just due to better vegetative growth that can dry out very quickly if there is a lot of heat. And so just wanted to make that point as to where we currently stand. Now, the upcoming forecast, to be honest, I don't see a strong MJO signal. I know we got a La Nina we're going to get into, and all that's coming up here in a few minutes, but I'm really just still focused on the way the jet stream level winds are behaving. And we start off this forecast time period with split flow. There's a northern branch and a southern branch. As we play it forward, I'm just looking for something coherent and deep and strong in this. And this isn't it. This is relatively weaker flow compared to what you can get at this particular point in spring. Now, there are a few troughs to talk about, like the one that's coming through here. This one's early next week. We'll take a look at the total precipitation from that. But if I'm looking for a big dominant signal, like look at these winds. They're staying pretty far to the south as we stretch this out beyond a week. And as that occurs, look at that. See this? As that occurs, that tends to take with it the storm track farther to the south, and it eliminates better rainfall getting across much of the rest of Australia as we begin to transition our seasons here. So this is what I'm talking about. These are troughs and ridges. The troughs are associated with the tail end of the jet stream creating deeper low pressure. That's in the cooler colors, and the ridges are in the warmer colors. So what I am watching is there's a system coming through late this week into this weekend. You can see it there. I apologize for the nose. I'm in a hotel in Lake Charles, Louisiana, and the toilet runs every 20 minutes. Kept me up all night last night, and I couldn't figure out. I didn't want to shut the water off to it, but it was a problem. So I apologize for all that extra noise. Anyways, back to Friday. There's our trough. Immediately following it, we have this big ridge that's here. And there's the leftover of that trough bringing in some of the rainfall you're going to see here in just a few minutes. But I'm curious about this, this massive ridge that's sitting in here, because if we were going to see the end of September going into October going over wet, you don't want this. That's the wrong signal if we're going to be looking for above average precipitation. So what we end up getting out of it is this. Let's play through the rest of the day on Thursday. Here we go. This is into Friday. Remember when the trough settles in? That's our best chance later in this week into Friday of getting some rainfall into this quarter, while the tail end of that front, look at it. That's the wrong orientation. They need to be more north-south than they run west to east. So this front's not bringing in a lot of rainfall into Western Australia or into, South Australia around Adelaide. But here, we've got better chances of moisture. So that just plays through Friday into Saturday, and it's kind of out. See that? And then a big area of high pressure tries to build in behind it. Now, we know that if we can take this high pressure center over here, then we're going to bring flow around it, and we're going to bring in the rain into parts of Queensland, New South Wales, these coastal regions. But that doesn't seem to be happening by next Wednesday and Thursday. And as a result, the storm track is south overall, and that high pressure cell tries to dominate a lot of the middle of next week. And even though we have another system out there, Friday the 26th, it's pretty far to the south, maybe hitting more of Tasmania than anything. So I say all of this because that's our most dominant feature right now, is where's the jet stream tracking these highs and lows as we work our way toward a seasonal transition. So we add it all up, and there's your Friday rains. Can you see them coming in through this area? This is early in the morning on Friday, playing through the rest of the day and getting into the weekend. So overall, what are we getting out of this? Drier coastal regions, drier or not dry. Wettest corridor could be right in through here, maybe back down toward the higher elevation. But as I play it on out, that's not a whole lot of additional moisture getting added to this. So we just stretch it out and say, show me 2 weeks and compare it to average. You can see where the storm track is. It's much farther to the south. And while there might possibly be better rains up here toward this section of Queensland, a lot of Australia is going to be seeing near normal to drier than normal conditions in this current pattern. So if we flip the script here and start thinking about temperatures, this is where we've been for the last 10 days when you compare it to average. Much more mild conditions down here in parts of New South Wales, Victoria, Tasmania, much cooler in Western Australia. But the pattern seems to be doing this. Over the next 5 days, quite mild to the north, a little cooler here in the southeast. We go to day 5 through 10. All right. Now, remember, this is when we have the frontal passage going through. We start to see the warm up because of the ridge that follows. And that's why the day 10 through 15 tends to be a bit more mild in the overall forecast. Okay, as we normally do, we try to get through the near-term stuff quickly because you have a lot of different resources to kind of keep an eye on that near-term forecast, including, my website, agweather.com. But I want to get into the longer range. So here's the first thing I did. I went out and I just looked at Australia, and I said, show me October precipitation back toward, it's back in World War II. And I wanted to find what gave us these spikes up, these really, really wet Octobers. And I was curious what it took to make that happen. So I'm going to start with the first thing, which is something called velocity potential. Now, wherever you see the cooler colors, that's where there's rising motion. This is the MJO. That's really what we're looking at here. It's the MJO combined with La Nina, El Nino, all of those things. Indian Ocean dipole. It's the result of the rising motion. And the best rising motion followed a corridor right in through here, meaning the MJO had to be somewhere over in phase like 5 or phase 6. Can you see that? Now, I'm showing you that because right now the MJO is not anywhere near that. If you go from today all the way through the end of October, the best rising motion seems to be in a corridor here, mostly in phase 2, 3, trying to work its way over to phase 4, 5, 6. But it is not anomalous enough. It's not a strong enough signal to say, oh, yeah, we're going in MJO phase 5. Get ready. It's going to be taking the lid off. We're going to get the storm systems to come through better, more access to moisture. I just don't see that. If you even go look at BOM's forecast, okay, so what I'm saying is we need to take the MJO, which is, right now technically in this null space here, and the forecast models have it going like that, okay? It would need to do something where it came around and pop, came out over here, phase 3, phase 4, phase 5. So it's kind of going in the wrong direction for that, which is why when you look out there September to November and you say, well, what's the wetter phases? Well, it's phase 4, it's phase 5, it's phase 6. And where are we going? More phase 7, maybe back over to phase 1, 2. See this? And so that's the wrong phase for a really, really wet October. So I then said, well, what do we need to have in terms of the jet stream pattern? Well, it's pretty clear. You got to drop a big trough and leave it between Western Australia and South Australia, right here. Big area of low pressure, a lot of cold conditions. Sink our highs here, one south of New Zealand, one way over here in the South Indian Ocean, and just get the pattern, coming around like that with a screaming fast jet stream. But the reality is we look out there and we don't see it. We actually see lower pressure, sitting in this region. And that's just where we begin the month of October. And the models kind of wash it out with time. They don't, but what they don't do is put really deep troughs of low pressure in a place to make it wet. So I show you that so we can zoom in on Australia and say, well, just give me an idea about what the 30-day outlook is for October. And there it is. You have some sort of La Nina tropical influence maybe happening here, better coastal rains, maybe a little bit better rains here, but we're not overly abundant in the precipitation prediction for the month of October based on some of the model output. Now, I want to compare this to a couple of other things, like, well, what was going on with those ocean temperatures? It is true that those wet Octobers, here they are, just some of them listed, had La Nina signals, had negative Indian Ocean dipole. We have both of those things right now, but it just seems to be a bit delayed in getting us the proper stuff to get this really going. So I look at those ocean temperatures here, and yes, they're cooling off. We've got the negative Indian Ocean dipole, but are we really getting the best rising motion to come into this region, which is what would promote better moisture in October, helping the subtropical jet stream and the polar jet stream really do more of effective movement of low pressure systems across Australia. So BOM's outlook, they're still quite similar to what they've been for the month of October. They're giving better chances of above average precipitation across most of the eastern half of Australia, but these aren't high, right? We're not way up here, but I still think they've bit more into the the La Nina signal than anything else. So what is that La Nina signal? This is what the new European model suggests. They've got the La Nina coming in and sticking around for most of October, November, December, January, and February when you look at the ensemble average. And this new model forecast is more aggressive than the previous model forecast. NOAA, National Weather Service, they're at a 72% chance for October, November, December that La Nina will be the most dominant global circulation. So that's their probability on it. But what's interesting is BOM's outlook. They have this La Nina bottoming out in October very weakly and then recovering very quickly. And I find that to be quite interesting because the other models are like, no, leave it down here and then bring it up in February. So take note of that difference, because if you're watching BOM's forecast, they may have differences in them because of the treatment of La Nina. But I imagine that they're also trying to hammer out what's going on with the Indian Ocean dipole, which is quite negative right now. And they're expecting it to make some sort of recovery as we go forward. But that negative IOD should put wetter conditions across the South, the whole of the South, from coast to coast. And so we need to weigh all of these factors and assess, and this is the thing I really want to get in and show you, how they're all influencing the new long-range forecasts. Now, every long-range forecast is going to have the same problem I've been barking about for months. They're going to bite into La Nina, and they're going to give you that historical perspective on it, which is October, November, December, wetter. See this? Let's go out there. November, December, January, wetter, especially east. Then you come out here and say, what about December, January, February, the heart of summer, wetter east, drier interior? I mean, that's a La Nina forecast to the T. And we also have new data that came out from the National Multi-Model Ensemble, a suite of 8 models run across North America, but they predict global weather. They're doing the same thing. October, November, December, drier Western Australia, wetter east. And you get out there and say, what about November, December, January? Same thing. And then they go out there into December, January, February. Still see wet east, but a mixed signal throughout the rest of Australia. And I'll even take you out there further. January, February, March is what they have. So again, the story has not changed. Every model's like, yeah, bring on the rain. It's a La Nina. It's what we're going to get. And I'm just going to remind you that every La Nina has a different flavor. And what I want to know is, as we get later into the season, do we keep seeing in spring deep troughs here? Does the MJO ever park over the Indian Ocean, which is common, not the Indian Ocean, Indonesia? That's common during La Nina. And do we get the resulting weather patterns as a result of it? So we've got those things to watch. The rest of the world's watching this too. And I'm going to show you a global map over the next 10 days. A couple of things to point out. We're getting rains moving through the midsection of North America. This is very dry. Our Mississippi River, which is our biggest river system in the U.S., is currently 6 feet below its low stage, meaning that we've got to get rain in this area. Our west coast is going to be taking on some rain, but to see this move through is going to be critical. Our hurricane season has been boring. Everything stayed out way out to open ocean. That's good for human lives, bad for moisture return. Elsewhere around the world, the other big spot I want to tell you about is South America. They are now fully into their planting, especially if there's soybean crop here. And over the next 10 days, they've got a big front that's going to sweep through and put in a bunch of rain, which means that front's not monsoonal, okay? The monsoon has yet to really crank and get going. But this front coming through here is going to knock the temperatures back, but not dangerously so, and bring in enough moisture that I think they're going to rapidly begin planting in this region. So that is just a couple of bigger picture things happening worldwide that I want to make sure that you know about. But with that, I'll wrap it up and I look forward to talking to you again in a couple of weeks. Thanks.